to another old-time steam-powered machine shop episode. This is number 22, and if you're not familiar with this channel, we do things here the way it was done 95 years ago in a small job shop, machine shop under steam power, and to see what that would be like and what the problems are and how they did it. And it was a long time before CNC, indexable tooling, digital readouts, and all that stuff. So I hope you enjoy it. Today I'm going to show you how we finished up the pulley here and cut the keyway and fitted it up. Also, the engine is mocked up here so you can kind of see how it goes together. And the flywheel slides on the shaft, and then it has what's called a gib key. It's a tapered key with a little foot on the end of it so that you can get a pry bar behind it and pry it out, and it wedges the flywheel tight against the shaft. And so we're going to make one of them on the shaper. And let's see, we re-machined the cylinder head for the cylinder because it was really pretty pitted from sitting outside for 40 years. These main bearing caps, I finished them up, cut the lubrication grooves in them, and also converted them to screw-in grease cups. I'll show you how we did that. Be taking a field trip here in a couple of weeks to go out to Wisconsin to pick up the Richards Ironworks engine out there, and also there's another engine I'm picking up at Stutzman's shop. It's a Lilly engine. It's about a 4x4, and we'll take you along on that trip. My trusty fireman and friend and apprentice Tom Vitale is here today, and he's going to start on the wrist pin going here, using the old one as a pattern, sort of, what was left of it. And so we got a lot of things for you today, and I hope you enjoy it. Thanks a lot for all the subscriptions, and we just passed the 1 million view mark last week, kind of a milestone. And I really appreciate the comments and the support you guys have given this channel, and other machine shop channels too. So we'll get to the machining end of it. Thanks a lot for watching. Getting set up here to machine the cylinder head for the Morris engine. We got a lot of really heavy pitting here. I'm going to take this surface down, get to the bottom of the pits, and then I'll have to machine this surface down an equal amount. This sort of goes into the cylinder and stuffs the space at the head end of the cylinder when it's on top dead center to keep the head volume down. And these are reliefs for the steam ports, which are right here when the engine is together. So then I'll flip it over and do a cosmetic cut on the back side, and then chuck it up here and maybe do a cosmetic cut on this. So I'm waiting for the steam to come up.
fine-tuned. Back here.
I got a 3/8 broach here. I got to broach a 3/8 keyway in this hub. And I've already taken one pass down through here with this in the press. And I was just going to show you this keyway is going to take several passes. And you put a shim behind the broach each time, an extra shim to bring the broach out for the next cut. But you got to be careful that this hub is really wide. It's about like that. You got to make sure that your shims go all the way down through so that the back of the broach is supported as it's going down through. Otherwise it puts a lot of bending stress on the broach and you might break it. Made this broach bushing out of the arbor that I was using to turn the pulley. The The main bearing cap for the Morris engine with the new Babbitt in it was designed to have cotton waste in here for the oiling, and that would hold the oil. You put the oil in here and that would slowly distribute the oil down through these holes to the bearing. Well, that was sort of before grease was invented. So what I'm going to do is just convert this over to a greased fitting, and the way I'm going to do that is to bore down into the Babbitt just a little ways and tap this fitting to just start down in that, and then I'll pour this whole cavity full of Babbitt, and we'll end up using a grease cup like this. I don't know if it'll be this one because this is the only one I got. I like to have a matching pair. This appears to be new old stock. It's really pretty cool the way these work. They're threaded with a very fine thread, and you fill this full of grease, and then every once in a while you just give it a turn. We got the Babbitt cooker out again, and this is just some junk lead. Junk Babbitt that I've saved out of other stuff that I don't know how good it is or what it is. We're basically just going to use it to fill in a space. This is lead type from a Linotype machine for newspaper printing. I used to work in a print outfit. They had tons of that stuff laying around. Gave it to me. I didn't have the Babbitt hot enough. It cooled down in between times, so I just cleaned it up with a chisel. And then if you want to just get kind of cosmetic about it, you can kind of puddle the stuff around just to make it look good. Okay, the next thing is we got to drill the hole for the grease and then cut the grooves in here to distribute the lubrication. Laying out the grease passages, slots, whatever you want to call them, is just some handwork with a chisel. I use a piece of shim stock, and you lay it in there so that it's pointing at the corners, and then just scribe a little line on here. I got a 1/4-inch hole drilled for the grease, and countersunk a little bit. Let's see, now I gotta turn this, I gotta flip it the other way. It's pointing at the corners. Okay, get this so you can see. And this is the chisel I use. You find these in flea markets, and people don't know what they were used for, so they're usually pretty cheap. This is an old Williams. They call them a cape chisel. They're curved on the bottom and flat on the top. And what I do is I kind of grind this off at a little bit of an angle so it won't hog in quite so much. And you just come out here, see which one of these I can do so you can see. You get it started, and then you kind of control the depth by the angle. And as you get closer to the hole, you let it get a little deeper. And if it acts like it's hogging in too much, you just twist it a little one way or the other and it'll climb out of its groove. Well, I'm certainly no master at this, but that's adequate. Turn this a little bit. Here's the finished product. Put the grooves in there. And we can take a little steel wool and kind of deburr it. You got to be a little careful about cleaning it up because you don't want any embedded emery cloth or steel wool particles or anything in your bearing. Okay, we got the engine sort of mocked up here. Things put together loosely to see what fits and what doesn't fit. Come around on this side so you can see. I have it sitting on this wooden base I made out of 2x4s. I'm going to have to fab up a engine base for it because it was not with the engine. And I have a good one from a photo that I can use for a reference. But it's got to be tall enough so the flywheel's got some clearance against the floor. Probably make it out of probably 3/8 plate steel. And then it'll have a tab on the bottom of it here with bolt holes front and back. Gonna have to make a tapered gib key for this keyway here, so it'll fit tight. And this bearing here needs to be hand reamed to fit the shouldered bolt that we made for it. This has just got an old junk bolt in here to hold it together for the time being. One sort of interesting thing is there's 4 frame bolts, 2 on the inside of this casting and 2 on the outside. Let's see, right there, right there, and one of those 4 bolts was bent, and I'm thinking, what could possibly bend one of those bolts? And I think it was just jammed really hard when whatever it was got caught in the engine and stopped it quick. And it shoved the frame against the base out of line and bent the bolt. And it's like a 5/8 bolt. Okay, laying out this gib key, I determined that it's got to be, it's 1/2 inch thick this way, and it's got to be 475 up here at the end and taper to about 460. So I got about 15 thousandths from there to there. So I figured the easiest way to do it is to cut the top of it square and then taper the bottom afterwards. And because the shaper is going this way, I could do it crossways, but it would take forever and it would leave machining marks going crossways. I didn't want to do that, so I'm going to machine it lengthways. And to do that, you can't just run the tool up to a dead end. You got to have some clearance in there. So I'm going to drill a little hole about 1/4 inch or a little bit bigger right here in the corner of this, so that when the tool comes up, it'll have a little clearance, little chip clearance between the end here. So that's what I did. There's the piece, and then I just made a hacksaw cut down through here. And when I get this machined, I'll go ahead and run it in, stand it up in the vise and run it in this way to smooth this edge up. And then we'll cut a 45 over here to make it look nice. And then I'll flip it over and shim this end up about 15 thousandths and run it down till it touches full length, and we should be at that. Ha! Okay, you figure out how much stroke you're going to want, and it looks like about 3.5 ought to do it. So you run the ram all the way back as far as it goes, right there. And let's see here. You run the stroke to, there's 3 between the 2 and the 4, and that's about 3.5. And then you position where you want the stroke to be over the work. So we'll go at the back and loosen the clamp on top. And then you run this back to, I got about 3/8 of an inch off the end of the piece. Tighten this down again, and then check it. See where you're at. Now this is a little tricky because I want this stroke to run just about halfway up into this slot, and it's not quite there. So I'm going to crank it up forward just a little bit right there. We'll try that. Okay. This is the down feed, feeds the tool down, and this is the mechanism to feed the tool, feed the piece across. And this is the ratchet pawl. And when it's turned this way, it doesn't do anything. When you turn it this way, it ratchets in this direction. When you turn it so that this flat is facing down, it ratchets in that direction to affect which way it moves the table. I don't want the table to go that way because I'm going to start on this side of the piece. So, set it right about there. And you can't leave the crank in here because the weight of the crank screws up this ratchet deal. So you got to remember to take the crank off. All right. We're ready to go. Higher gear that it shakes the floor, makes the camera jiggle. Short stroke.